An object moves in a straight line according to the position versus time graph shown. Part A is to rank the speed of the object in each of the 4 labeled regions of the graph from fastest to slowest, and if any 2 regions have the same speed, to indicate that explicitly. So, on a position versus time graph, you know that the slope of the graph is the velocity. So positive slope is positive velocity, negative slope is negative velocity, but speed is just the magnitude of the velocity, and that's what we're ranking here. So we're not going to pay attention to the positives and negatives. We're just going to look at basically the absolute value of the slope. So we're going to rank the slopes from the steepest to the shallowest. So if you look at region 2, that is a slope that goes down by 2 squares and over by 1 square. And if you look at region 4, that goes up by 2 squares while going over by 1 square. So 2 and 4 are the 2 steepest slopes on the graph, and they have the same magnitude of the slope, even though this one is negative and this one's positive. So we can start by writing the answer to this one as region 2 is equal to region 4. Then the next steepest region is, you see region 1 over here that goes up by 3 while going over by 2. So we can put this in the list as this is greater than region 3, region 1. And then region 3, there's no slope to it at all. So that has a speed of 0. So we can put the final part of this, that this is greater than region 3. And you can just write that down for your justification, that speed is the absolute value of the slope, and just talk about the steepness of the slopes going from highest to lowest. Part B is to draw the corresponding graph of velocity versus time on the velocity versus time axes. So we'll have to get the slope of each region of the graph. So if you look at the slope of region 1, it goes from 5 up through 20. So it's a rise of 15, and it goes from 0 to 2. So 15 over 2 has a slope, which I'll just write the number directly on this graph. 15 over 2 is a slope of 7.5. Next region of the graph is going from 20 all the way down to negative 10, so it drops by 30, and that's in a time of from 2 to 5 seconds, so 3 seconds. So negative 30 over 3 seconds gives you a velocity of negative 10. Next region, since it's a horizontal slope, that means the rise is 0, and 0 over anything is still 0, so it has a speed of 0. And then region 4, it goes from negative 10 up through positive 10 in a time of 2 seconds, so that is a velocity of positive 10. And now you can see, referring back to part A, that region 2 and region 4 have the same speed, because we don't take into account the direction. Both of them have a speed of 10 meters per second. So let's go ahead and get this drawn on the velocity versus time graph. It started out with 7.5 meters per second for the first 2 seconds, so it's just a constant velocity. It's really close to the 8 meter per second mark, but not quite there. Then the next region, between 2 and 5 seconds, had a velocity of negative 10, so it's halfway between the negative 8 and the negative 12. Next region had a velocity of 0 for the next 3 seconds, from 5 to 8 seconds. And the final region had a velocity of positive 10, that's for the last 2 seconds, so halfway between the 8 and the 12. So that's what the graph would look like if you want to. You don't have to, but you can connect these with vertical lines. Part C, determine the distance, displacement, speed, and the average speed and average velocity over the full 10 seconds. So notice these questions say determine and not calculate, which means the answer is probably a little bit easier than what you're expecting. The distance, you just look at where it started and just add the numbers together. It started at 5, I went to 20, so that was a distance of 15. So I'll put distance. So it went up 15 meters. Then it went from 20 meters down to -10. So that was a distance of 30 meters. Remember, distance is always a positive because it's the magnitude. So plus 30. Next region, it didn't move, so that was 0. Plus the final region, where it went from -10 up to +10, a distance of 20 meters. So 15 plus 30 plus 0 plus 20 gives you a total distance of 65 meters. The displacement is even easier because remember, displacement, we don't care about the path it took. We just care about where it started, which is at 5 meters, and where it ended, which is at 10 meters. So if it started at 5 meters and ended at 10 meters, the displacement from 5 to 10 meters is just 5 meters. Speed and velocity are easy to calculate because remember, speed is just distance over time. So take the distance we got earlier, 65 meters, divided by the time interval for the full graph, which is 10 seconds, and you get an average speed of 6.5 meters per second. And velocity is just equal to displacement over time. The displacement we got earlier was 5 meters divided by 10 seconds, and that gives you an average velocity of 0.5 meters per second. And in part D, you want to draw a motion map for the object on the number line beneath the graphs. And you want to do each dot 1 second apart. So the object is starting at the 5 meter mark, and after 1 second, it has moved to the roughly 12.5 meter mark, 12.5 meters, and at 2 seconds, it's at the 20 meter mark. So we can put a first dot at 5 meters with an arrow going in that direction. Next dot was at 12.5 meters with an arrow going in that direction. Next dot is at 20 meters, but now it's moving back it's starting to move back in the other direction, so I have to shift the dot up a little bit so I can start going backwards. Next dot at 3 seconds will be right here at 10 meters. At 4 seconds, it's going to be at 0 meters. And at 5 seconds, it's going to be at -10 meters. So this dot right here will go down in this direction. It's got a slightly faster velocity at this point, so these arrows are a little bit longer. We said the next dot was at 10 meters. And then we have a dot at 0 meters going this way. And then the next dot is at the -10 meters, but at that point it stops moving for 3 seconds. So we're going to have a dot with no arrow, a dot with no arrow, and another dot with no arrow. And when we get to the fourth dot, it starts moving the positive direction again. So the fourth dot, we're going to have an arrow going in the positive direction. So it'll look like the first dot with no arrow, then stack them up, and then the second dot with no arrow, then the third dot with no arrow, and we said the fourth dot, this is the one that gets an arrow, and this is going to go in the positive direction. Next dot is going to be at 9 seconds, is at 0 meters. So we'll put the next dot right there, and then it's going to go to the next point, and then it ends at 10 meters at 10 seconds. So you don't need to put a final dot on there as long as you have that last arrow heading towards that direction.